Okay, hello, bonjour, everybody. Welcome. Am I coming in loud and clear? Let me know on the chat. Can you hear me out there? Hello, Advaita. Wyon, hello, hello. How is everybody going? Um, Gosh, the term is almost over. Can you believe it? It's week 9. Whew, where did the time go? Um, anyway, in today's tutorial, I thought we could do some algebra questions around things like linear systems, and matrices, stuff like that. Um, and you might have seen that some of these questions are in the lab test practice questions. Now, I've already done a couple of classes on that. So what I might do, I might just talk about matrices a little bit more in this class. And then if people have extra questions about, lab test or something like that, then we can talk about them in the second part of this tutorial. Okay, so I'm hoping this is going to be relevant for you. So let me have a look at this. I know when I have talked about some of these problems before in other tutorials, people weren't quite up to date on like leading rows, leading columns, non-leading columns, leading elements, these sorts of things. So I thought we might have a look at this and try to refresh our memory of what's going on with these kinds of problems. Okay, so this is what I'm going to talk about first, and then after this, I might do some systems of equations or linear systems, and we can talk about that. And then afterwards, we can talk about whatever you like, really. Okay, so um, this is I think a really good question. Okay, so for each of the following augmented matrices, right? They have these things here. We're asked to do the following. Determine if the matrix is in row echelon form. Okay, so row echelon form. If the matrix is in row echelon form, identify the leading elements, leading rows, leading columns, and non-leading columns. Now, there's a lot going on here, and so I'm going to do these quite slowly because they're interesting, and I think it's harder to do the more advanced problems if you don't know these things. So that's what I'm going to concentrate on at the start. Okay. All right. So who can tell me? Let's have a look at matrix A together. Is this in row echelon form? Okay. Who can tell me on the chat? Is this in row echelon form? Advaita thinks so. Okay. Well, let's look at this a little bit more. Okay. You can see if I circle the leading entry, so I go to each row and I go past all the zeros and I find the first non-zero term. And you can see as I go from top to bottom, these first leading entries move from left to right. Okay, so this definitely is in row echelon form. Okay, there's no rows of zeros. If there were rows of zeros, they'd be at the bottom. Okay, so you can see over here there's a row of zeros, and that's definitely at the bottom. Okay, so the leading elements. Okay, I think what they mean there is the leading element from each row, right? So 3, 4, and -7 would be the leading entries. from each row. From row 1, row 2, row 3. So we go along the row until we find a non-zero entry and we circle it. That'll be our leading entries. Okay, so are there any non-zero rows? Well, that one is, that one is, that one is. There's nothing like this. Okay, so we would say row 1, row 2, and row 3 are all leading rows. Okay, because they all none of them are all zeros, and they all have a leading entry, right? All right, leading columns. Let's have a look at this. Let's go to the columns. Okay, so I go to column 1, and I see, does that contain a leading entry from some row? Well, yes, it does. Okay, so if it contains a leading entry from some row, it's a leading column, right? So this is column 1. Column 2, does that contain a leading entry from some row? Yes. Column 3, does that contain a leading entry from some row? Yes. Column 4, does that contain a leading entry from some row? No. So C1, C2, and C3 are all leading columns, but C4 is not leading. Okay, so C1, C2, C3 are called leading rows. C4 is not leading. Okay. Okay. So that's it. We've circled our leading entries. We've identified our leading rows. We've identified our leading columns and our non-leading columns. Okay, Russell, good question. Why is C4 not leading? Because it doesn't contain one of these circled numbers. Okay, it doesn't contain a leading entry from some row. Does that make sense, Russell? It doesn't contain one of these leading entries. Yes. No. No, that's not true, Russell. Okay. So no, we're not comparing the numbers. We're just saying that if I look at this row contains a leading entry from the first column. This column contains a leading entry from row 2. This column contains a leading entry from row 3. This column doesn't contain any leading entry from any row. Okay? Right? So there will be situations where C4 is leading, but not in this case. Okay, so it's quite tricky because there's a lot of things to look at here. So what I usually start with doing is go to each row and find the first non-zero term, okay, and circle it. Then I look at the columns and say, okay, are any of these circled numbers in the columns? Okay, that's quite interesting and it's quite time consuming, but once you know what to do, you can make it much faster. Okay, let's move on to this one. This is a very simple one. So we've only got one row. It's not full of zeros, so it's a leading row. So row 1 is leading. What is the leading entry of row 1? Well, we go down from left to right and we circle the first non-zero number. So 3 is the leading entry or the leading element of row 1. Okay. Now let's have a look at the columns. there are 1, 2, 3, 4 columns. Okay, so let's look at column 1. Does column 1 contain a leading entry? Yes. So column 1 is leading. Does column 2 contain a leading entry? No. Column 3? No. Column 4? No. Okay. So we would say C1, so a column 1 is leading, a leading column, but C2, C3, C4 are not leading. Okay. And I mean, this is in row echelon form as well, by the way. So I guess we should say that that's also in row echelon form. Okay. So hopefully you're seeing a pattern now. Let's see if we can move on to part C. Okay. Let's look for the leading entries of each row. Okay. So that's a non-zero. That's a non-zero. What have you got there, Bill? Oh, my dog's got a sock. Okay, so that's a non-leading row, and that's the first non-zero entry from left to right. Let's move here. This is a non-zero row, and that's the first entry. That's non-zero. So, and if we look here, this is a non-zero row, and that's the first entry. Okay, so row 1. Oh, well, I guess that we don't actually have to do that, because who can tell me? Does this entry lie to the right of this entry? No. So this is not in row echelon form. It doesn't have this kind of movement to the right of the leading entries as you go from top to bottom. Okay, so this is not in row echelon form. Okay, so according to the instructions, we actually don't have to do anything with that. Okay, because it's not in row echelon form. Okay, so how's everybody feeling about this? Is it starting to make a little bit of sense, or be a little bit more familiar? Let me know in the chat, or let me know what's going on, and how are you sort of coping with this sort of analysis here? Okay. Cool, Abdul Rahman. Okay, let's move on to part D. Okay, part D goes, all right, let's look at row 1. It's a non-zero row, so it'll have a leading entry. There's the first non-zero entry. If we move down here, that's the next the first non-leading entry, first leading entry in row 2. Okay, so this lies to the right of that. So this is definitely in row echelon form. Row 1 will be leading, and row 2 are leading rows. Okay, 3 and 4 are the leading entries, or the leading elements. And what about our columns? Okay, does column 1 contain a leading entry? Yep. So column 1 is leading. Does column 2 contain a leading entry? Yes. What about column 3? Is column 3 a leading or not leading? Who can tell me on the chat? Is it leading or not leading? Correct. It's not leading. And column 4 is not leading. Okay. So we would say column 1, column 2 are leading. Column 3 and column 4 are not leading. Okay. So there you go. So it's in row echelon form. It's got a couple of leading rows, a couple of leading columns, and these are not leading over here. Okay. So I know we're going very slowly here, but I think this is an important step when you identify all the leading and non-leading parts. I think that's really important. Okay, so let's move on to part E. Okay, so let's look at the first row. The first row is not all zeros, and if we move from left to right, that will be the leading entry. If we move over there, that will be the leading entry. Okay, now you can see the leading entry, they move to the right as we go from top to bottom. So this definitely is in row echelon form. Okay. Column one will be leading, row one, row two will be leading. And then the question is, what about the columns? Okay, so let's have a look at column one. Who can tell me, is column one leading? Who can tell me on the chart? Is column one a leading column? Who can tell me? Yes or no? Nope, correct, because it doesn't contain a leading entry of some row. Okay, what about column two? That's definitely leading. Column three, definitely leading. Column four is definitely not leading. Okay, so C2 and C3 are leading, whereas C1, C4 are not leading. Okay, I'm just trying to squeeze all this in. Sorry if it's a bit messy. Okay, now, so what's the point of all this analysis? The point of this analysis, in part, is to help you make a judgment on whether a given linear system has a solution or infinite solutions or no solution. Okay, so that's kind of where we're going with this. But it's hard to make those judgments if you don't set it up right and do the groundwork. Okay. All right. So let's do one more, and then we can talk about a slightly different variation on this. Okay. So let's look at column one. There's the first non-zero entry of row one. There's the first non-zero entry of row two. There's the first non-zero entry of row three. Now, row four is full of zeros, so that can't be a leading column, okay, by definition. So if I was doing this one, I would say row one, row two, and row three are leading. And the entries or the elements for those are 3, 4, and -7. Okay. Okay. Over here, they would, the leading entry would be 3 and 1, right? So, okay. Row 4 is all zeros, so it can't be leading by definition. All right. Now let's look at the columns. Yep. So who can tell me on the chart, which ones of these columns do you think are leading? Which ones? Who can tell me? Who can tell me which ones are leading? Advaita, columns 1, 2, and 3. Thank you. So if I look at column 1, that contains that leading entry. If I look at column 2, it contains that leading entry. Column 3, same. Column 4 doesn't contain any leading entries. Okay, so column 1, column 2, column 3 are leading. Column 4 is not a leading column. Okay. All right. So let's change direction a little bit and see what can we actually understand or work out from this information. Okay. All right. So let's go back to the first augmented matrix. Okay. And let's pretend that this was the coefficients and the right hand side of some linear system. Okay. So what can I deduce about the linear system from this row echelon form? Okay. So there's three situations. Situation one, there's a unique solution. Situation two, there are infinite number of solutions. Situation three, there's no solution. Okay, so if you have a look at this, all the left-hand columns are leading and the right-hand column is not leading. So what does that mean in terms of solvability? Can anyone tell me whether they can understand if this has a one solution, infinite number of solutions, or no solution? Okay. So Advaita says this has one and only one solution. And that's the case in general, where you have the left-hand columns are all leading and the right-hand column is not leading. Okay, so for this one, this information back here means that there is a unique, oh, actually, I'll just group them into bits. So let me put them up here. So an infinite number of solutions. Oh no, my dog just stole my toy. Just give me a second. I'll be right back. Okay, I'm back. Okay, my dog in the background has learned how to jump. Can you see? Can you see the dog? It's over there. It's learned how to jump up on the bed, and so it's been like trying to eat my plushies. Anyway, you leave it. All right. So let's have a look at the next one. Okay. Minnie, get off. Trying to juggle dogs. Anyway, so with the next one, what do you notice about this one? You've got one leading column and two non-leading columns on the left-hand part of the augmented matrix, and the right-hand column is not leading. So who can tell me what situation would this give you? A unique solution, in an infinite number of solutions, or no solution? Who can tell me on the chat? Who can tell me? An infinite number of solutions. Absolutely, Advaita. Okay, so this is definitely going to have an infinite number of solutions because some of the left-hand columns are not leading. Okay, so that would be part B. That would be an infinite number of solutions. Okay, and just give me a second. Settle down. All right. So, what about the next one? This is in not in row echelon form, so we can exclude that because it's not in the form that we want. What about part D? Okay. Who can tell me? Get out. Okay. Sorry, I'm just going to put the dog outside. Meaning you used to be cool, and this is how you repay me. Okay. All right. So let's look at D. All right. Russell and Advaita think infinite number of solutions. Okay, why? Why? So you're correct, but why? Why are you thinking that for part D? What would be some of the justification for that? Who can tell me? So you're absolutely correct. Column 2, 3, and 4 have no leading column. That doesn't make sense, Russell. Yeah, so I think going on Russell's comment, column 3, there's at least one column on the left-hand side that isn't leading. Okay, so that must have an infinite number of solutions, right? So I'd add that to the list. That's okay. Yeah, Advaita, it's a bit like that, although it might not, like the line and the plane might not intersect at all. So there is a situation where there might be zero solutions. Okay. But yeah, it's good. It's definitely good to try to think about these geometrically. Okay, but that's fine. Okay. What do you think about this one? Okay. Is this, which case, unique solution, infinite number of solutions, or no solutions? Who wants to have a go? Russell and Advaita, yeah, infinite number of solutions, right? Are you sure, Advaita? Because column 1 is not leading, so there's at least one column on the left-hand side that's not leading. So I would say E would be, yeah. Yeah. Okay. What about this one? Which one? Unique, infinite number of solutions, or no solutions? For part F. Yep. So all the left-hand columns are leading and the right-hand column is not leading. So I think you're right there, Russell. Okay. Let's have a look at maybe where there's no solution. What about part G? Okay. Part G, if you look closely, it's in row echelon form. And if you look at the leading entries from each row, oh my God, you can see that column 4 contains a leading entry. So as Ashwin has said on the chat, There's no solution, right? It's the same as saying 0x plus 0y plus 0z equals 6. There's obviously a problem, okay? So G would be in the no solution category, okay? And with this one, this is not in not in row echelon form, okay? Because the rows of zeros are not at the bottom, okay? But you could just swap these over and then make a judgment, okay? So if I was to swap these over, I would swap row 3 and row 4 to get something like this. Okay. And now the question is, well, this is now in row echelon form. If I go to each row and I circle the first non-zero term, you'll see that, oh my goodness, the right-hand column is leading, which means no solution for H after we've put it in row echelon form. Okay. So this one is not in row echelon form, but we can put it into row echelon form and then make a judgment. Okay. So what questions do you have, people, on these linear systems? Okay. Is there anything you want me to repeat, or anything you want me to make a bit clearer? Just let me know. Because what you're trying to do here is set this up to make a judgment on unique solution, no solution, or infinite number of solutions. Okay. All right. So let me keep those questions coming on in the chat. Let me move forward a bit. I thought it might be helpful to talk about using these problems in an actual linear system. So I thought we could talk about something like this and something like this. Okay. So you can see with the first one, you've got 3 equations and 3 unknowns. And in the second one, you've got 3 equations and 4 unknowns. Okay, so these aren't that difficult, but sometimes you need to introduce a parameter. Like in part B, what will end up happening is you need to introduce a parameter, and some students, they're not quite sure how to make the choice or to do that. So I thought we could work through these. Okay. All right, so let's look at the. I'll just do part B, I think, because that's probably the most interesting one. Okay, so this is 13 part B. All right, so I'm just going to write down the augmented form. So you take the coefficients and you write them down as a matrix. And you get something like this. Okay, and so the question is this in row echelon form? And the answer is yes, because if I go to row 1 and I circle the first non-zero term, it's there. If I go to row 2, if I go to row 3, that's where it is. Okay, so column 1 is leading, column 2 is leading, column 3 is leading, column 4 is not leading because it doesn't contain these entries here. Okay. Column 5 is also non-leading. Okay, so what does that tell us? It tells us that, well, there's at least one non-leading column on the left-hand side. What it means is that there will be an infinite number of solutions to this problem. Okay, so C4 is not a leading column. And so there will be an infinite number of an infinite number of solutions, right? Okay. All right. So what do we do? Well, one way here is look for the non-leading columns on the left and introduce. So this is your like your x1 column, x2 column, x3 column, x4 column. Let that non-leading column in the variable be your parameter. Okay. So whatever the non-leading columns are, you let that variable be the parameter. Okay. And so from here, once you've let lambda equals x4, from here, you can just start at the bottom row and then do what's called back substitution. Okay. So this says negative 7x3 plus 14x4 equals 14. Okay, so if we rearrange that and divide by 7, you'll get this. 2x4 minus 2. Because we've let this be the parameter, it's going to be 2 lambda minus 2. Okay, so we've let that be that. We've got x3 in terms of lambda. Now let's get x2 and x1 in terms of lambda. Okay, so R2, what's R2 going to give us? Okay, I could simplify this just by dividing the row by 2 or something, but I don't know if I'll do that at the moment. So row 2 equals 4 times x2 equals 8 minus 2x3 plus 4x4. X3. Okay, so I've got an expression for x3, it'll go here. I've got an expression for x4, it'll go there. Okay. So all I want to do now is simplify this and divide out the 4. Okay, so I'm going to get 8 plus 4, which is 12, minus 4 lambda plus 4 lambda, but 0. So x2 is going to be 3. All right, I've got x2, x3, x4. Let's get x1 from the very first row. All right, so it's going to be 3x1 equals 10 minus 2 times that, minus 1 times that, minus 1 times that. And now we just back substitute all these bits in here. So that's going to be 6. That's going to be that, and that is lambda. So now we just simplify these bits, and we're going to get 6 minus 3 lambda. So we divide the 3 out, and we'll get negative lambda plus 2. Okay, So it's taken us a while, but that is almost finished now. Let's write these as a column and we can finish. Okay, so this is obviously going to be a line because we've got one parameter, lambda. Okay, it's not there, but that's okay. And it's going to be something like this. So x1 is that, x2 is that, just 3, x3 is that, and x4 is that. So I'm going to break that up into the constants and the lambdas. Okay, and this is lambda. Okay, so this is a line. The line is going to pass through the point associated with this, and this is going to be a vector that's parallel to the line. Okay, so it was quite a long process to do by hand, of course, but this is called the method of back substitution. All right, folks. Well, I am going to stop the recording now because there might be some questions about the exam and the lab test too and stuff. So let me stop recording.